Welcome back to the shop. So today we're going to take a look at some breakers. We had some fail. This one you can hear is still sort of flipping. This one not so much. And this one here it's a similar style, I think. I couldn't get one of these, but we'll take it apart as a control. So here's the rivets. We drilled them all out. Let's take a look at the inside of this breaker here. First, make sure nothing goes boing on me, and see what happened. So, it appears as though the contact tip is just burned right up. This should be down in there, like that. And you can just see that contact tip is just wasted. Absolutely wasted. So, that ain't gonna work no more. Now this is a bolt-in breaker, and you can tell that by the tab here. That's where the bolt goes into the bus. And then here's the other piece that would have gone on the lever mechanism. I don't know if I can hold this together and operate it. Doesn't seem as though it all wants to fall into place very well. But there we go. This is part of the mechanism here. There are also pieces in here. So I think this thing burned up. There you go. But this should lift up. The spring's supposed to be on there, and it's not. I might have done that though. I have a feeling what happened was this thing started getting hot, and it just started. You can see this is actually bent. I think that was actually from this spring tension here, bending it. Because when it was arcing, this spring was pulling on this tab here. I have to get a needle nose to put that back on. And then through the process of all of that, okay, those plastic pieces that came off were the operator. So that broke when we were playing around there. There we go. That just broke now, but it was very, very brittle. So then when you throw this piece comes over and latches up like that, and that's supposed to have this contact. Nope. Supposed to have that contact on there, and then as this heats up, current goes through this mechanism here. You can see the bonding wire from this contact down to here, and this is a bimetallic element, and as it heats up, the breaker, it moves, and the breaker should trip into the open position. So for whatever reason this didn't do that, and it burned the heck out of that tip. I'm gonna be curious to see what's inside door number 2 here, because this one is really, really bad. So this one also has the busted pieces from the operator, and that's actually why it stopped working. But when we got to this, it would sort of sit there and arc, which you could hear it arcing because it wasn't making proper contact. So I don't know if these operator buttons had just gotten broken or what's going on with these. We replace the breakers, and we'll just be paying attention to it to see what happens. There you go. You can see that doesn't even want to hold anymore. No, it'll hold. So let's get a control breaker open here. See if the mechanism inside is the same. It should be similar, I think. Nope, not even close. But at least we'll have a look at what's inside of one of these. So this is a GE breaker. I thought it might have been similar, but it's not, turns out it's not. But this has some interesting things going on in it. Here's some arc suppression. So that is in there. You can see like that. The contact, let's see if I can do this without having something go flying. Okay, so the contact is closed like this. Let's see if I can get that out. Contact is closed, and when the breaker trips, let's see where the trip is. Okay, so when this thing trips, the cover's missing, so it's kind of hard to do this. But when this trips, the bimetallic element heats up right here, and when that heats up, it opens all this up. Now, this needs to happen quickly, and what these do is they draw the electric field away from the contact tips. I don't think these are magnetized. No, they're not magnetized, but sometimes in contactors you'll have a permanent magnet in here, and that helps pull the arc away. But this is arc suppression, which is very interesting because we don't even see anything attempted on this Siemens breaker. So this old GE breaker actually has arc suppression in it, which is kind of cool. So let's get this thing reset here. So to reset it, we're in the trip position. To reset it, we need to turn it off. Now the mechanism's holding, and then we should be able to turn it back on again. So there you go. You can see it's closed again. So there we go. Pretty neat that has arc suppression in it there. That's not something I was actually expecting to see in a breaker like this. Now these contact tips are actually domed. I don't know if we can see that, probably not. But there's a little dome on them. They're not perfectly flat. So if you ever see anybody, this goes for relays too, if you ever see anybody in there with a file trying to clean something like this, it's a really, really bad idea. Because part of the arc suppression is that radius on that tip to get the arc starting to go away from the point of contact in the center. So bad idea to take a file to this. And the way this is designed, as this were opening, these attract the arc to them, and that's what dissipates it. So interesting little find there. I was hoping to see the similar type breakers, these Siemens, and get them to operate for us so we could see exactly how they were working. But I think we get the gist of it here. This mechanism flips over much like this one, and then as this bimetallic element heats up, you can see that would fall like that, and that would create the contact to open up. So it's similar, but it's different. So there we go. That might be about closed, and then if I tripped it, you saw it opened up there. So the same, but not quite. So I just thought we'd take a look at that. It appears as though these things were welding. You can see there's an awful lot of arcing that was going on here, and it just melded the tips off of these contacts inside. You can just see that there's completely melted, and that's what the death of this thing was. What caused that? I can't say. I don't know if somebody opened it under a high current condition and created a burn mark on it, and then it just progressively got worse. A lot of times guys will use breakers as a means of switching. Really shouldn't do that, and you know, maybe we can start to see why here, but this is kind of interesting to see. It definitely got hot in here, and that created you know, this piece of plastic. The heat made this brittle, and that was actually ultimately the operator going bad was ultimately what got us out there, because the guys went to flip this thing on, and it started arcing and everything inside because it wasn't getting its proper throw. So that obviously not a good situation, and needed to be fixed. So hopefully that was interesting. You can see where the adjustment to the bimetallic is behind this screw here. They epoxy that in so you can adjust it. Good idea. But that would put torsion tension on this here, and that changes where that would trip, and that has to be set by professionals in a lab. But that's the adjustment on that one. And then this one here, this one's adjusted right here by this screw, set in epoxy again. Don't want you playing around with any of that. And that's what sets the bimetallic on this one. So hopefully that was interesting, taking a look at some breakers. This was a interesting find, the arc suppression there. That's actually a good trait for the breaker. The contacts should last a lot longer with some sort of arc suppression. So GE was on their game with that. And this actually looks a little bit more robust inside than what these are, even though this one's melted. But I'd say these are, even though these feel chintzy, that actually seems to be pretty good. You can see the arc is supposed to follow this path out the breaker here, just like this one should follow it out here. But either way, this is pretty nice. I don't even think we saw that in the Square D breaker we had apart. Maybe what we'll do is we'll try and get some other breakers apart and see what they look like inside. But for now, hope this was interesting, and thanks for watching. Have a great day.